Yes, beta, we'll continue with the numericals of the concentration or solution part. Solution has 40 gram of common salt. A solution is made by taking 40 gram of common salt and it is dissolved in 320 gram of water. That means this is solute 40 gram and this 320 gram is a solvent. Calculate the concentration in terms of mass by mass percentage. So we have to use only the mass in the formula of calculating the concentration. That is, we have to calculate the percentage of the solution. So first of all, we write the amounts which are given. So first is the mass of the common salt which is given. Mass of common salt which is a solute. This is equal to 40 grams. And then mass of water is given, and water here is a solvent which is equal to 320 grams. And what is the mass of solution? Because in case of concentration we need the mass of solution also. Mass of solution is equal to mass of solute plus that of the solvent. Mass of solute plus mass of solvent. This is 40 solute and solvent is 320. So mass of solution is 360 grams. Then we have to write the formula. Whenever we are doing any numerical, we have to write the formula that we are using this formula to solve this numerical. So mass by mass percentage of solution we have to calculate, which is equal to mass of solute upon mass of solution into 100. Mass of solute is 40 and mass of solution is 360. After solving this, we will get 11.1%. So this is the concentration of solution. We have calculated the concentration using the masses of the solute, solution and solvent. So now moving on to the second numerical. 36 gram of sodium chloride is dissolved in 100 gram of water. Now this 36 gram is mass of solute and 100 gram is the mass of the solvent. And after dissolving 36 gram into 100 gram, we have got a saturated solution. Find the concentration of the solution. So same way we have to solve this numerical. First write the mass of solute, that is sodium chloride, it's common salt only, and the amount of this is 36 grams. Then mass of the solvent, that is water here. Mass of solvent water is 100 grams. And what is the mass of solution? Because for concentration we need to calculate the mass of solution. This is equal to mass of solute plus that of the solvent. Mass of solvent. Mass of solute is 36 and solvent is 100. So this is 136 grams. Then we have to write the formula, that is concentration. Now concentration and mass by mass percentage means the same thing only. Since here in the question concentration what is written, find out concentration, so we write concentration here. While in this case what was written, calculate concentration only, but they had written in terms of mass by mass percentage. So we can write mass by mass percentage here, or we can write the concentration word also here. So here I am writing concentration, which is equal to mass of solute upon that of the solution into 100. Now fill the values here. Mass of solute is 36, mass of solution is 136. This comes out to be equal to, after calculating this, 26.47%. This will come out to be equal to 26.47%. This is the concentration of this solution. So after doing the numericals of concentration, our next topic now is the suspension. We have done the true solution. Now moving on to the next type of the solution, that is the suspension. How the suspension is different from true solution. Suspension is a heterogeneous mixture. It is a heterogeneous mixture, while true solution was homogeneous, where the components they mix up uniformly. While in suspension, the components of the suspension, solute and solvent, they don't mix up uniformly. That is why this is called heterogeneous mixture. And in this, in which solute particles are of very big size, that is why they are not mixing up uniformly into the solvent. And if the size is big here, the size is more than that of 100 nanometer here. So size of particles here is very, very big. Example of suspension, we can take muddy water or sand in water we can take. Then paints is the example of suspension. Lime water, that is calcium hydroxide, when we dissolve in water, that becomes lime water. All these are examples of suspension. After doing the suspension and its examples, we are doing some properties of suspensions. In the properties of suspension, we can mention one thing, that it is heterogeneous in nature. First characteristic is it is heterogeneous mixture. So heterogeneous means when the components they don't mix up uniformly. Second characteristic we can write is particle size is big. And how much we have mentioned here? Particles of suspension are greater than 100 nanometer. Greater than 100 nanometer. If particles are of big size and when we do the filtration of this solution, then what will happen? The particles, since they are very big, they will not pass through the pores of filter paper. So particles do not pass through the filter paper. That means we cannot separate the solute from solvent by doing the filtration. Next characteristic is that since particles are very big, so they are visible to naked eye. The size of 100 nanometer, more than that, is visible to naked eye. So particles of suspension can be seen with naked eye. And of course with the help of simple microscope also. And particles, they settle down when suspension we leave it for some time. That means suspension is not stable. The solute will start separating out from a solvent here. So if you will take the water and add some sand into that, after some time what you will see, the particles of sand in suspension, they will settle down when a suspension is left undisturbed. So we can say that suspension is unstable. So suspension is unstable. Next is suspension is opaque. Opaque means if from one side, if you have taken suspension in a glass container, from one side if we'll start seeing the solution, we cannot see anything onto the other side of this solution. So suspension is opaque, and some suspensions we also see are translucent. Translucent means in this case the things are a little bit visible. They are not clearly visible but little bit visible onto the other side. These are the properties of suspension and what is suspension. Similarly, now we're doing the third type of solution. We have done true solution, suspension. Now third type of solution is a colloid, and colloid properties are intermediate between the true solution and suspension. These are the type of solutions which are actually coming between the true solution and the suspension. So these solutions are also heterogeneous in nature. And one thing we remember, they appear to be homogeneous, but actually these are heterogeneous mixtures. And particle sizes between 1 nanometer to 100 nanometer here. So it is between the true solution and the suspension. So here the particle size is little big as compared to true solution. Example is milk, blood, soap solution, ink, All these are colloidal in nature. Now, when we form a solution, we say that there are two components. One is solute and the other component is solvent. But when we are talking about colloids, solute in colloids is called dispersed phase and solvent here is called dispersion medium. Just the name only will change, otherwise dispersed phase is solute only and dispersion medium is solvent only. Now, next, to understand this thing, true solution, colloid and suspension, just see the main difference here is in the properties is because of the size of the particles here. If I take this as true solution, this as colloidal solution, and suppose this is suspension. Particle size in case of the true solution is less than 10 raised to power minus 7 centimeter or less than that of 1 nanometer, we can say 10 raised to power minus 7 to 10 raised to power minus 5 centimeter. And here the size is greater than 10 raised to power minus 5 centimeter. This is the size of the particles in case of true solution, colloid and suspension. Now just to understand, see, same volume suppose we have here in these containers, and the particles here in this case, they are so small, so that is why the number of particles here, they are more in number. And see, all these, they are uniformly mixing up. The distance between all these particles approximately is the same. Like this we will have the true solution. Particle size is like this. But if we take colloids here, the particles will be little big in size, and that is why they are less in number as compared to particles packed here in a true solution. And little bit they are in a random way, like this. And when we come to suspension, the particle size is very, very big. So the number again here, what will happen, will be less even than those of the colloidal particles, like this. So this is about the colloids. In colloids, we have a dispersed phase and dispersion medium. The size of particles is from 1 nanometer to 100 nanometer. These are heterogeneous in nature, though they appear to be homogeneous in nature. Now, after this, we are doing the type of colloidal solution. These also are of the further of 8 types. First, we have done solution, which is true solution, colloid, suspension. But colloids further, now these are of 8 types. And this is very, very important topic. Types of colloidal solution. These types of colloidal solutions are now based on the physical state of the dispersed phase and dispersion medium. So this classification is based on, depending upon the physical state of dispersed phase and dispersion medium. So how many types are there? 8 types of colloids are known. In this we are writing them in a tabular form. Dispersed phase, then in next column I will write dispersion medium. Now name of this, they will have specific names here, and then we will write 1 or 2 examples of each type. First, now here is the, if dispersed phase will take is a liquid, then second I'm writing is solid, third is a gas, then fourth, if dispersed phase here is a liquid. Now next fifth is when it is in a solid state, sixth is gas, 7 is liquid, and then again I'm taking is a solid. So it's like liquid, solid, gas, liquid, solid, gas, liquid, solid, but we don't have a gas here in this case. Now next one here is gas, and then I'm taking is a liquid dispersion medium, liquid, liquid, and then the last three are solid, solid and solid. So what are their names now? If liquid dispersed phase is dissolved in a gaseous dispersion medium, if dispersion medium is gas, this kind of colloid is known as aerosol. So see now again here, this is also in a gaseous form. So this is also called aerosol. Just two colloids are there where dispersion medium is a gas. So dispersion medium is gas, that this type of the colloidal sol is known as aerosol. If gas is dissolved in liquid, it is called foam. Liquid in liquid is called emulsion. Solid when dissolved in liquid is known as sol. When the gas is dissolved in the solid, it is called solid foam. Liquid dissolved in a solid is called gel, and when solid is dissolved in solid, then this is known as solid sol. Solid sol we will get. Now come to the examples of these. In examples we are writing here aerosol example, when liquid dissolved in a gas is mist, fog, clouds. And when solid is dissolved in a gas, like in a air, smoke, dust. Then gas in a liquid is soap and whipped cream. Cream is there which is liquid, so when we are beating it, that is this gas will come into this cream. Next is the emulsion. Emulsion example is milk and face cream. Solid in a liquid, that is starch, sol, and muddy water. These are examples of solid in liquid. Then gas in a solid is a pumic stone and then sponge. Liquid in a solid example is cheese, butter, jelly. Solid in solid is alloys, the colored gemstones that we use in the jewelry. These are examples of solid sols. So these are the type of colloidal sols depending on the physical state or dispersed phase and dispersion medium. Now we will do the properties of colloidal sols, which will be from these things only that we have covered up so far. That is properties of colloidal solutions. First property, like we have done, that these are actually heterogeneous in nature, though they appear to be homogeneous, but actually they are heterogeneous in nature. Then particle size is from 1 to 100 nanometer. And third is, here also particle size is small, so they can pass through the pores of filter paper. So not possible to separate the solute from the dispersed phase, we can say from dispersion medium doing the filtration process, but they are quite stable. But very important property shown by the colloidal solution is they show Tyndall effect. What is Tyndall effect? When we take a colloidal solution, place this in a dark room and throw a light on this. The light, when will pass from the solution, will split, and this part, this cone which is formed, it will get illuminated with which color? With a blue color. So this bluish light we will see only in the case of the colloidal sol. This phenomenon will not be observed in case of the true solutions, and even this bluish light scattering like a cone will not be visible in the case of the suspension. So this scattering that has happened, scattering of light, is by the colloidal particles of this solution. Next property here is colloidal particles are visible under ultra microscope only. The particles are small here, So they are not visible to naked eye, not even under a simple microscope. To see these particles, we need a ultra microscope. Then only these particles are visible. And when we see these particles under a microscope, we'll find that these particles are moving in a zigzag way. How these particles are moving? These particles move in zigzag path, and this is known as Brownian motion. The zigzag movement of these colloidal particles is called Brownian movement. And this movement is like this. Suppose this one particle, we are focusing on this particle. When we see this particle under this ultra microscope, we see this particle moving in different directions in a zigzag way, like this. So this zigzag movement is possible only in the case of the colloidal solutions. And this movement is known as which movement? That is called the Brownian movement. And why the particles are moving in a zigzag way like this? Because the dispersed phase particles, they collide with the dispersion medium. So when they collide with this, then their direction and speed is changing. That is why they move in a zigzag way. So these are the properties of the colloidal solutions. With this, this topic is complete. That is, solutions are of three types: true solution, suspension, and colloids.